Okay. So one more sorting algorithm, that is called it as, what is that? So that is topological sort. Topological sort. So what is this exactly is nothing but here there are two methods are there. In topological sort, there are two methods. Okay, there are two methods. Okay, na? So what are those two methods is nothing but one method is called it as DFS method, depth first search. Okay, DFS method. Another method is called it as source removal method. Okay, source removal. Okay, na? Source removal method. Clear? Both the things I will going to explain. Just observe here. Now see here. First, what I will going to do, using DFS, I will going to solve the problem. Okay, using DFS, I will going to solve the problem. Again, after that, using source removal method, I will going to solve one more problem. Okay, na? Fine, everyone okay? Now see here. Let's take a problem. Simple. Actually, this is very easy. Let's take a problem. What is that problem is nothing but take one graph. Okay. What type of graph is nothing but that is DAG graph. Directed, please understand here. What kind of graph is that is DAG graph? What is that? Directed acyclic graph. So what is this directed acyclic graph is nothing but here it is a directed one. So and in this directed acyclic graph there is a one condition. What is that condition is nothing but the graph should not have, okay, graph must not have cycle. Must not have cycle. Oh sir, I will show you that one also, don't worry. So what is that cycle is nothing but, suppose example, take graph vertex A, okay, again vertex B, again vertex C. See here, so from A to C I will going to connect, again C to B I will going to connect, again B to A I will going to connect. If C you can able to see from A to C I can able to go, again C to B I can able to go, again B to A I can able to go. So this kind of graphs we will going to call it as a cycle graph. This is a cycle. It is a graph is creating a cycle. So these kind of graphs are not eligible, or these kind of graphs are cannot be identified as a good for topological sort. Understood now? If the graph has a cycle like this, okay, so graph must be DAG graph. Understood? Directed acyclic graph. Nothing but it should not have a cycle. That one is very important actually in this graph. That one you have to understand. Okay, fine. Everyone okay with this? Again, I will going to take a graph. Please understand there is a graph. I will going to show you the graph. Please observe here. One graph I will take it. Okay, one graph, simple graph I will take it. Okay. So what is that graph is nothing but A. Okay. Again B. Fine. C. Again here D. Okay. Again one more here E. So this is the graph. Again I will going to put the directions here. A to B. Okay na? Fine. Again A to D. I will going to connect from A to D. Fine. Again B to D. See, any cycle is there here? No cycle. Okay, any cycle is there? No cycle. That one you have to understand very clearly. Again, from B to C, I will going to connect. Okay, B to C, I connected. From A to C, I will going to connect. Any cycle is there? No cycle, nothing is there. Okay, again, I will going to connect from D to E. See here? Okay, again, C to E. These kind of graphs are, we will call it as a, what is that? DAG graph. Again, one more important, very important thing is here. If you want to go to B, please observe here, there is a vertex A. Again, there is a vertex B, correct? Again, there is a path between A and B. So how you have to write this one means A comma B, you have to write like this. You cannot write like this B comma A. The reason is before see, if you go to the B, then only A will get finished. Nothing but what is that exactly? If you want to go to B means A support is required here. Yes or not? A support is required. If you reach B, then only A is over. Correct or not? Then only A is over. So that is the reason why always vertexes are represented as a, please observe here, vertex as a represented a first one, represent as a U, again second vertex, that is destination vertex, that is represented as a V. So this is the general formula. Okay. So that is the reason why I written like this, A comma B, nothing but what? So this is the first vertex. From here to here I am moving. So without A, I cannot able to reach to B. So that is the reason why first you have to write the vertex A. After that, you have to write the vertex B. If you want to reach the vertex B, you have to finish A first. Nothing but you have to visit the A first, then only you can able to visit the B. This is the meaning. Okay, this is the meaning. Now see here, sir, how to do this one topological sort using DFS, depth first search method. So how to do this one? Okay. So I said you very clearly, we will going to use this method. What is that method? Very simple. See here, everybody observe here. I will going to select, I will going to create one table. Everybody please observe here. I will going to create a table based on this particular graph. See here. Okay. Again, see here. Fine. Again, line is not right. Okay. Now okay. Okay, that is also okay. No. Okay, fine. Yeah. If you want it, you can keep serial number also. But I don't want serial number also. If you want it, you can keep it 1, 2, 3, 4 like that. No problem. That is also okay. Again, here I will tell you. Oh, 1, 2, 3. Here one more. Okay, here one more I will take. What is that? Here one more. That is enough. Enough. These things are enough. More than enough. Okay, these things are more than enough. I will go to label now. Everybody observe here. I will go to label now. So what is this? This is serial number. Don't worry. If you don't take, nothing will going to happen. But this one is important. Selected vertex. Okay. Again, adjacent vertex. Adjacent vertex. Okay, fine. Again, here stack. Okay, again here popped vertex. Popped vertex. Okay, clear? So here I will going to create one stack. There are 5 vertices are there. You create 5 one array here. So which is having 5 spaces. 3, 4, 5. Leave it. This is the stack actually. Okay, now clear everyone? This is the stack actually. Now everybody observe here. So what I will going to do? I will going to solve the problem. Okay, I will going to solve the problem. Everybody, please see here. Now see. Now, what is this topological sort do? Basically, DFS is nothing but what? You will going to use the stack. Yes or not? You will going to use the stack. Okay, now see here. Everybody observe here. But here, one important thing you need to understand, which vertex you have to start here. That is the main reason. Okay, which vertex you have to start here. That is the main reason. Yes or not? So what is this exactly? Topological sort is nothing but you have to visit each and every vertex. Okay, you have to visit each and every vertex. That is our ideology here. Okay, again, which vertex you visited first, you have to mention that one. So that is what we call it as topological sort. You have to visit each and every vertex. Okay, once. Again, you have to identify that which vertex you visited first. Again, according to that order, you will go to represent it. Okay, that is what exactly we will do. Now, see here. Everybody, please observe here. Let me start. Now, the real story will going to start now. Now, cinema will going to start now. Now, see here, everyone. First, what I will going to do, basically, one more thing. I forgotten. One more thing I will going to tell you. So, here, there is a vertex A. Again, vertex B. There is a vertex C. Think like that. Assume. Please assume. Here to here, there is a connection. Okay. Ear to ear, there is a connection. Clear? Everybody observe here. Ear to ear, there is a connection. But think here. So from B to C, there is a connection. Is there any cycle here? See, A to C, I can able to go. Again, B to C I can able to go, but C to A I cannot able to go. So this kind of graph we will call it as, please observe, this kind of graph we will call it as DAG graph, direct acyclic graph. Okay, so then what you have to do, what is the in degree of B? That is 1, because from A to B I am moving. What is the in degree of B? That is 1. Again, what is the in degree of C? That is also 1. From B to C I am moving. What is the in degree of C? Here also you are getting nothing but 1 plus 1. What is the value totally? In degree of C is what? Directly, that is 2. Understood how to get the in degree? Again, that is the reason why start from A, because the in degree is 0 here, A in degree is 0. So that is the reason why always start from this vertex. So that is what I wanted to tell you. That's why, see, observe here in this diagram, everybody observe here, A to B, correct? Okay, fine. Again, from A to D, correct? Yes or not? Fine. Again, A to C, that is also fine. Now what I will going to do, I will going to start, anyway the in degree of A is 0. So that is the reason why what I will going to do, I will going to start from A. Please observe here, I will going to start from A. Now that is the reason why, which vertex you will going to select as a source vertex, that is A. So source vertex you select as A. That is what the meaning is. That is the reason why I said all this story here. Okay, got it? Raghu, got it, Raghu?
Yes.
Okay, fine. Now I selected the vertex. That is one, you will going to call this one as serial number. If you write, if you don't write, nothing to worry. No need to require this column also. Okay. So if you want it, you write it, otherwise not at all required. Okay, basically it is not required. Simply I'm writing, not required. If you want, you keep it, but these things are required. Okay. So what is the vertex I selected? That is called it as A. Okay. Now see the adjacents of this vertex. Okay. A adjacents are what? B, again D, again C. These are all the adjacents. Yes or not? So these are all the adjacents. So then which adjacent you want to visit first? You decide. Which adjacent vertex you wanted to visit, you decide first. I wanted to visit B now. Okay, please understand. First I will going to visit B. From here to here I will going to visit. Okay, from here to here, A to B I will going to visit. So that's why I will going to select the vertex which is adjacent, that is B. Okay, na? Understood everyone? Now you select the vertex A. So that is the reason why anyway you select the vertex A. DFS says that if you select the vertex, what you have to do? Push that vertex into the stack. So that is the reason why I select the vertex A, and that adjacent which one I will going to reach, that is B. Now whatever the selected vertex, that vertex I will going to push into the stack. That is called it as A over here. Okay, na? That is called it as A over here. Fine. Clear everyone? Okay. Everyone okay now? Everyone okay? Okay. Now see here. What about adjacent? We have adjacent, that is B here. See here, we have an adjacent, that is B here. That is fine. Now we push the stack. Okay, what is that element? That is called it as A vertex. I pushed into the stack. Okay, now see here. So which one you select the adjacent word? So I started from here. A, yes or not? I went to B. Here I went to B. Yes or not? I selected A. After that I went to B. Now select the adjacents of this particular B. Select the adjacents of this particular B. B having two adjacents. One is C, another one is D. Correct? One is C, another one is D. So select the adjacents of B. So that is the reason why I will going to select the B here. So hence I am selecting the B. So that is the reason why push this B into the stack. That is the reason why I am pushing the B into the stack. That's it. Again, what is the adjacent of B? So that is one is C is there, another one is D is there, another one is D is there. Which one you wanted to visit? Please observe here. So what I will going to do, I will going to mark it. I will going to write a diagram for this particular. What is that? This particular diagram. I will going to write it. You please observe now. 1 minute. I will want to run this so that it will be. Shall I remove this? Okay, I have anyway. I have space, right? I will write it. Okay, first one what we visited, A to B. I will going to mark that one here from here to here. Okay, so that is A to B. Done. So we have visited, what is that? A to B, that is done. Okay, done, done, that is over. Again, now you decide. Please, you decide now. Now you decide. I am in B now. Which vertex you have to visit? Whether you wanted to visit C or whether you wanted to visit C, visit D. You have to decide that one. Yes or not? You have to decide that one. We don't know exactly. Which one you wanted to decide? No problem. What is there in that? So you tell me which one I wanted to visit. Okay, you tell me which one I wanted to visit. That is left to you people. So what I will going to select? Okay, I will going to select. What I will going to select? I will going to select the vertex that is C. Please observe here. I will going to select the vertex that is C. Now nothing but what? B to C I will going to visit here. Okay, na? Fine. Nothing but what? What is the adjacent I am asking? Adjacent I am asking is C. Yes or not? Adjacent I am asking is C. Yes or not? So that is what exactly. You have to select the vertex. After selecting the vertex, push that vertex into the stack. That is the reason why I selected A. I pushed into the stack. Again, what is the adjacent I selected? Yes or not? What is the adjacent I decided? That is B. Again, I selected B, that one. Again, I pushed into the stack. Again, now I selected C as adjacent here. That one I will going to visit. That one I selected. Now C, select the vertex, that is C. I will going to select the vertex, again push into the stack. Okay, now push into the stack. That is what you have to do. Clear, everyone? Everyone clear now? Okay, so that is also over. Now we came into C. See, observe here. We came into C from C. Okay, where you can go. So we are at the C. What is the adjacent of C? Everybody observe here. What is the adjacent of C here? So C having only one adjacent, that is E. I can go here. Yes or not? So I will going to select adjacent vertex as CE here. Now, so that is also done. After that, now you please observe here. Adjacent, we got it. Select the adjacent now. That is called it as E. Okay, if you select the adjacent, what happens here? Push that selected vertex into the stack. This is stack. Okay, now clear? Everyone okay? Everyone okay? Yes or not, guys? Everyone okay? I think no problem. Yes or not? I think no problem. Now see here. Now this is over. Now E having any adjacents here? No adjacents. What we have to do now? What we have to do? Tell me. What we have to do? E don't have adjacents. Okay, here I will going to say very clearly. See here, I will going to say E don't have any adjacent. E don't have any adjacent. Adjacent vertex not there. What I have to do? When you don't have adjacent vertex, just what you will going to do? Just please pop that vertex. Pop that vertex from the stack. Where you will going to pop? I will going to pop the vertex into the popped vertex, that is E. Nothing but this vertex goes off. Yes or not? This vertex goes off. Nothing is there. Over. There is no adjacent vertex. Please understand. There is no adjacent vertex. Yes or not? There is no adjacent vertex. Okay. That's why what I did. So there is no adjacent vertex. That is the reason why what I did. I popped that vertex. Whatever the E we had. Here we had E, right? So that one I popped here. Yes or not? I popped and I pushed into the popped vertex. Again, what I did. Okay. What I did. So this A is available in the popped vertex. That's it. Over. Yes or not? Now you people tell me. That's it. Over or not? Okay, fine. That is over. Now, please observe here. Again, I will come back. Okay, so I visited E. That is fine. C to E visited. That is fine. But we don't have adjacent. What to do? What to do now? Okay, what to do? Again, come back to C. Please understand. Come back to C. Okay, come back to C. Okay, because we have to visit all the vertices, right? Come back to C. Again, what we will going to do? We will going to select the vertex. We will going to select the vertex that is C. Yes or not? We will going to select the vertex that is C. Yes or not? Okay. Again, go to the C. Go to the C. Check it. So what are the adjacents you have for C? Any adjacents is there? C. For any adjacents is there? C. No adjacent, nothing is there. For C, any adjacents are there? Nothing is there. So that is the reason I say that here adjacent vertex is not there. Adjacent vertex is not there. Adjacent vertex. What you have to do now? Again, pop it out. Okay. Again, pop it out. So pop this vertex. What is that? C will going to pop it. So where it will come? It will come here. Okay, it will come here. Fine. Nothing but what? I came here. I came to see. Nothing but what? This one. I came to see, but there is no adjacent. What do you have to do? So that's it, over. Yes or not? Okay, that is fine. Over. So I will going to remove this vertex here from here. See here. Okay, I removed. Yes or not? I removed. Over. Again, what is left? Here in the stack B is left. C is also over. There is no adjacent vertex is not there. Then which vertex you will going to select? Now you tell me which vertex you will going to select. Okay, which vertex you selected? How you came from B, you came, right? How you came from B, you came. Nothing but you will going to select the vertex again B. Okay, you will going to select the vertex again B. Now see here. From B to C already visited. You can observe here. From B to C already visited or not? From B to C already visited. Again C to E already visited. Now what is not visited? D is not visited. Yes or not? So from B I can able to go to the D, right? So that is the reason why I select the adjacent one, that is called it as D. Okay, select the adjacent one, that is called it as D. Done. Yes or not? Done. Any problem now? Any problem? Nothing is there. Okay, after that. So no need to push anything, because no need to push anything because already B is there. B selected, B is on the top. Okay, again come to select the D. Please here, select the D. Okay. Yes or not, guys? Okay, select the D now. Okay, what we will going to do? We will going to push the D into the stack. Okay, we will going to push the D into the stack. Okay. 1 minute. Okay. Now we will going to push the D into the stack. Nothing. Fine. That is okay. Again, see here from D to from D, any adjacents are there? E is the adjacent. Already visited E. Yes or not? Already visited D. So E is already visited. Sorry, E is already visited. So that is the reason why no need to worry here. That is the reason why no need to worry here. Again, D don't have any adjacent also. That is what exactly D don't have any adjacent. Adjacent is there. D vertex, any adjacent is there. No vertex is there. Now what I will going to do? I will going to pop the D also here. So it will come here. Over. Okay, done. Okay, fine. So done. Everybody okay? Again, what is left here actually? Now everybody tell me what is left here. B is left. Yes or not? So again, what I will going to do? I will going to select the vertex. Again, I will going to select the vertex. That is B. Yes or not? That is popped out already. That is popped out already. Okay, what is left here? B. B vertex is left. Again, check with B. B having any adjacents? B having any adjacents? Already everything is completed. Nothing is there. Nothing is there. Yes or not? No adjacents again. Again, no adjacents for B because all vertices are visited. C also visited as well as D also visited. So that is the reason why I will going to write here D. Okay, D also visited. C also visited. D also visited. Any left is there? Any vertex is left? Any vertex is left? Nothing. As well as adjacents also finished. So that is the reason why I pop the B also. Over. Here over. Yes or not? Here also over. Then remove that B from the stack. Okay, done. Okay. Now what is left? Now what is left? A is left. Select that vertex. That is your choice. You have to select the vertex. Yes or not? You have to select the vertex. What is that? Finally, left is A. Again, see here. A having 3 adjacents. B also visited. Yes or not? D also visited. Yes or not? C also visited. Yes or not? So then what is there to visit? Nothing is there to visit. Just you pop the A from the stack. So that's it. So from bottom to top. Okay. So you reverse it. Reverse this one. Reverse this one. Automatically you will going to get the topological sorting. What is that exactly is nothing but if you reverse this one, you will get A, B, D, C, E. So this is what we call it as topological sort. Over. That's it. Over. Game over. Okay, na? Tell me any doubts. Please let me know any doubts is there. Aish, Chetan, Anwar, Raghu, Chetan. Any doubts,
No,
Chetan?
sir.
Anwar, any doubts, Anwar? Aish. Any doubts? Raghu, any doubts, Raghu? Simple, that's it.
No, sir.
Okay, so very simple. So whatever the result you will going to get it, reverse that result. So you will going to get the result. Okay, that's it. This is called it as topological sorting. So what is the result actually we got it? E, C, D, B, A. So just we reverse this one, reversed. Just we reverse this one. So this is your answer. Over, that's it. So this is what we call it as topological sorting. Okay, fine. So this is using DFS method. DFS method is nothing but use the stack. Stack use the stack. This is what exactly. Very simple actually. Fine. So let's see one more method, that is source removal method. So that it will take another 3 minutes. That's it. Nothing else. Not more than that. Okay, simple one actually. Let me take one more. Okay. Now I will take. Fine. Now see here. So what I will going to do now, one more thing I will going to do, that is called it as source removal method. Please observe here, source removal method. Okay. So let me take one graph. Okay, let me take one graph. That graph is something like this. 1. Okay. 2. You can take A, B, C also, no problem. That is the reason why maybe they will going to give like this. Maybe they will going to give like that also. They will going to use the A characters or numbers like that. That is the reason why different I am taking. Okay. Because you should not get confused. 3. Again 5 year. So this is the graph. Okay. I will going to collect from year to year. Okay. From year to year, I will connect. From year to year, I will going to connect. So when you want to do the sorting, topological sorting, okay, topological. So you must have a graph that is called it as DAG graph, direct acyclic graph. Okay, that's it. This is very important. If you don't have that acyclic graph, you can't do anything. Okay, because it won't give you the answer. Fine. Now see, let me complete this graph. Now I will connect from here to here. I'm not getting graph properly. Okay. From here to here. Again, if you want it, you take the weights are not required. Just directed graph is enough. One thing you have to understand, one thing, it must be a directed one. Directed, okay, it should be directed because we have to visit each vertex, right? Must be directed. And DAG, sorry, nothing but no cycles in the graph. Okay, in the graph. Fine, so this should be there. Okay, I think okay, everything is okay. Let's solve this one. Now see here, everybody, let's solve this one. So what happens here? What happens? Now I told you very clearly, one more time I will going to write this diagram. See here, one more time I will going to write this diagram so that we can able to solve properly. Okay, let's take a diagram 1. Okay, so that is 1 to 2, again 2 to 3. Sorry, not here. So this is 4, right? 4, again here 3, again here 5. This is the graph. Yes or not? So year to year, I will going to connect from year to year, again from year to year. Okay, again from year to year, I will connect. From year to year, I will connect. So this is the graph. Now, please understand how to get the degrees of this particular graph. Degree is what here? See, what is the degree? If any incoming path is there like this, any incoming path, so then we will call it as in degree. In degrees, we have to identify. Already I said, yes or not? Already explained about the degrees. Now see here, what is the degree of vertex 1? That is 0. What is the degree of vertex 2? That is 1. Again, what is the vertex of 4? That is, here also it is coming from 2 to 4 it is coming, and 1 to 4 it is coming, that is 2. Again, what is the vertex? What is the in degree of 3? That is 2. Because here, this one. Okay. What is the in degree of 5? That is 1. Correct? Everyone okay with this in degree? Any problem with the in degree? Hello, any problem with the in degree? No, right? I don't think so. You don't have any problem with this. That is what exactly we got it here. Okay, please understand. That is what exactly we got it here. So what is the in degree of A? That is 0. What is the in degree of 2? That is 1. This one is missing here. Okay. What is the in degree of 3? That is 2. What is the in degree of 5? That is 1. What is the in degree of 4? That is 2. So everything is done now. Everything is done now. So what I will going to do? I will going to construct a new graph. I will going to construct a new graph. What is that exactly? See, in degree is 0 here. Okay, in degree is 0 here. What I will do? I will going to remove this vertex. Okay, I will going to remove this vertex. Remove the vertex. Remove the vertex. Vertex 1. That is what we call it as source, because it is a source, right? 0. You have to start from here. So it is a source. What I will going to do? I will going to remove the source. Nothing but vertex 1. I will going to remove it. Nothing but what happens? In degree will going to change or not? Here in degrees. Okay. In degrees will change or not? Will change. Now for for new graph, please observe here. For new graph, in degrees will going to change here. So what is the new graph now? New graph. I will going to write the new graphs here. Everyone observe here. Okay. So new graph is 2. Correct. Again 3. Again 4 year. Again 5 year. Okay. From year to year. Correct. From year to year. Yes or not? Again from year to year. Yes or not? Again from year to year. Fine. That is 1. Now see here. Before it was getting in degree 1. Okay. So 1 minus 1. This is already over. Yes or not? 1 minus 1. It is over. That is the reason why. What is the in degree of 2? That is 0 now. So now see here. What is the in degree of 3? Basically 2 you are getting. Again, what is the in degree of 4? Hence before you are getting 2. Because 1 minus 2. It gone. This is 1 minus 2. What is that? So gone. That is 1 only now. Right now 1 only. What is the 5? That is 1 only. This is the new graph. Please understand. This is the new graph. Yes or not? Now tell me, what is the source you will going to take now? What is the source you will going to take? Source you have to take, that is 2. Source you have to take, that is 2. Now remove the source. Okay, remove the source now. Okay, what you will going to do? Remove the source. Again, in degrees will going to change or not? In degrees, again it will going to change. Okay, in degrees, again it will going to change. What is that exactly we will going to get it? 3. Okay, again 5 you will going to get it. Again 4 you will going to get it. Correct? Now from year to year. Okay, from year to year. So what is the in degree of 4? That is 0. What is the in degree of 2? In degree of 3? That is 1. What is the in degree of 5? That is also 1. Remove this one also again. Remove this one also. What is left here? 3 as well as 5. What is the in degree? 0, 0. Yes or not? In degree is what? 0, 0. Yes or not? Now, please understand. Okay. First, which vertex you removed? Please observe here. First, which vertex you removed? First, 1. Correct. Again, second, which vertex you removed? 2. Correct. Again, third, which vertex you removed? Okay, this is first step. Step 1, step 2, again step 3, again step 4, again step 5. Okay. So now, first, which one you removed? That is 1. Again, second one, which one you removed? That is 2. Third one, which one you removed? That is 4. Again, fourth, which one you removed? 3. Again, 5. This is your topological order of this particular graph. That's it. Over. 1, 2, 4, 3, 5. Again, many graphs you will going to get for topological sort. Not only this, you can go for this also. 1, 2, 4, 3, 5. That is also okay. 1, 2, 4. Maybe if you want it, you can remove this one. So instead of 1, 2, 4, again 5, 3 also okay. This is also okay, no problem. So this is called it as topological sort. Okay, that's it. Any doubts, please ask me now. Any doubts, Ayush, Chetan, Raghu?